Okay, the molarity formula, molarity is abbreviated with a capital M, not a lowercase, is moles of solute over liters of solution. It has to be liters at the bottom, and you might be given volume in milliliters. So just a reminder, there are 1,000 milliliters in 1 liter, in case you forgot that conversion. Okay, so let's look at the first example in your notes packet. Find the molarity of a solution that contains 42.5 grams of magnesium chloride and has a final volume of 0.5 liters. So the formula for molarity is capital M equals moles over liters. We have our liters, 0.5, but I did not give you moles. Instead, I said we had 42.5 grams of magnesium chloride. You're going to see a lot of times you'll be given grams, not moles. It's not to be mean, but if I'm making a solution, I have to weigh out my solutes on the balance. The balance weighs things in grams, not moles. So that's why you'll be given it in grams. People have to weigh the solute on a balance. So 42.5 grams, we will need to change to moles. Now, magnesium chloride, you do have to write that formula correct. Magnesium has a charge of 2. Chlorine has a charge of 1, so that is MgCl2. And we need to change it to become moles. So 1 mole MgCl2, and then at the bottom we'll have to put our grams of magnesium chloride. For the sake of time, actually I don't know what it is. So magnesium, go to the periodic table, add up magnesium into chlorines, and there are 95.211 grams in 1 mole. So that is 0.446 moles of MgCl2. Now that I have my moles, I can plug it into the molarity equation, which I'm going to rewrite down here. Molarity equals moles over liter. So 0.446 moles over 0.50 liters. And that is 0.892 molarity. That's our final answer. Okay. The second problem. How many grams of sodium nitrate are in an 800 milliliters of a 2.2 molar solution? So this one's going to be the opposite. This time I've given you the molarity and I want grams. So our molarity equation is moles over liters. We have our molarity, 2.2 m. Our solution, we don't know moles. And then we have 800 milliliters. 800 milliliters is 0.8 liters. I got that by dividing by 1,000. 800 ml divided by 1,000 is 0.8 liters. So this time I'm going to work backwards because I want to find grams of sodium nitrate. I have molarity, I know liters, I want to find my moles. Then once I have moles, I can solve for molarity. Now, we need to get moles by itself. To isolate this variable, we're going to multiply each side by 0.8. That will cross that out, and I'm going to finish my work up here. Now we have 0.8 times 2.2 equals moles. Multiply those, and that is 1.76 moles. Now the problem didn't ask for moles, it wanted grams, and again, this has to do with making solutions. When you make a solution, you weigh out your solute on a balance. And so this is sodium nitrate. Sodium is Na plus 1. Nitrate's a polyatomic ion. It is NO3, 1 negative, so that formula is NaNO3, and we're going to have to change that to grams. So 1.76 moles NaNO3 times 1 mole NaNO3 at the bottom, and then we need to add up our grams of NaNO3 up top. So go to your periodic table. Sodium plus a nitrogen plus 3 oxygens is 84.994 grams, I believe. Then multiply that out. And we get that equals 149.589 grams. With significant figures, and there should be 2, you would have 150 grams of sodium nitrate. And that is solving for, molarity. So molarity is moles divided by liters. You might be given grams, or you might ask for grams. Remember, you can always go from moles to grams. You've been doing that since December. No, honestly, October, September, whatever. You know what I mean. And so those are the 2 molarity examples.